Okay, so compounding periods. So compounding periods refers to the number of times the a in a period that the interest is calculated. So the we calculate the future value or the present value. The we we may encounter compounding periods. For example, your mortgage or your car payment is going to use monthly compounding. Most bonds use semi-annual, twice a year. So monthly, 12 times a year. Quarterly, 4 times a year. So everything we've done so far has been annual compounding. So this would be in this case we determine a future value by adding the interest earned once per year, or our present value we discounted it once per year. So semi-annual compounding, determining the future value of a cash flow or series of cash flows when interest is added twice per year. We would also calculate the present value using the same methodology. The future value of a lump sum, I actually mentioned this early, future value of a lump sum will be larger if interest is compounded more often. Um, Given the same interest rate. Why is that the case? Because you're adding interest more often. Compounding is more frequent than once per year, semi-annually, quarterly, or so daily, so forth. We won't do any daily calculations, but it does raise. But honestly the biggest difference is we'll work through a few examples. Uh, just the fact that compounding is included as opposed to annual. Uh, but anyway, compared to annual compounding, greater amount of interest is earned when interest is compounded more than once per year. So you don't the I don't know why we even have this R simple. Just ignore it. The APR is the rate that we're going to refer to. And then the effective annual rate is the rate that your actual earn. The APR is what's required to be disclosed when you are borrowing. With investments, most investments are going to state the EAR because it's higher than the APR. So, and vice versa for loans. Um, the R simple is not written into contracts. APR is written into contracts. Um, the rate per period is the APR divided by the number of compounding periods. So that would be our APR divided by number of compounding periods. The EAR is the rate used to compare returns on investments with different payments during the year. They uh, and again APR. I don't know where they come up with this. Maybe they're right, but the APR is what's required by law to be stated, and the periods per year must be given. So, for example, 8% compounded quarterly. The There we do have a formula. So it's 1 plus 0.08 divided by 4, in this case for quarterly, to the 4th power minus 1. And that's going to give you that'll give you a decimal. Just 1 second. Okay, this would give you 0.0824 or 8.24%. Um, the So if we were to do this using this is EAR, using a daily, it would be EAR would be 1 plus 0.08 divided by 365 to the 365th power minus 1. And let me do that calculation. Okay, so that this one is 0.0833 or 8.33%. You're probably thinking this is kind of an ugly formula. I don't really want to use this. So your calculator has a function. It is ICONV. All right, so that is above the 2. So you hit second and ICONV, and the first thing you're going to see is NOM. That's your APR. So in this case, that would be 8. And then you CY is compounding, C/Y, that's compounding periods per year. So quarterly would be 4. And then you go to EFF, which is EAR, and you hit compute, and that's going to display 8.24. Go back to CY and change it to 365, and you have to hit enter when you, just like anything like the cash flow function, so forth. So 365, enter, go back to EFF and hit compute, and you'll get 8.33. Much easier than using the formula. So the um, so, okay. All right, we'll do a couple more examples of this at the beginning of the next lecture.